All right. So yeah, sorry in advance. It's going to be a lot of information in these 10 minutes, but I hope it's worth it. So I will talk about what we are doing with 3D data in this application where we try to automate infrastructure design and management. And before the presentation, I realized that the overarching theme in my career has been trying to model reality, of course, all the 3D environment, but in a way that we can interact with it and not really for gaming, but for applications like the infrastructure management I will show you today. So it all started with my PhD. My PhD was about driving simulation in the very, very early stages of virtual reality technology. And as you can see, the idea was to model this very complex urban environment. So graphics were really simple at that time, but the complexity of the traffic and all this environment was really, really challenging. Then I moved to the US and I worked for Esri, which is a big GIS, Geographical Information System company. And in 1998, then Vice President Al Gore had defined this idea of the global digital Earth, like having what we call today a digital twin for the whole globe and being able to manage our resources, etc., with this tool. So we developed our globe at Esri. I was part of that team. And then back in Spain, I created a company with some colleagues that are today in the audience, Julio and Jesus, and we try to combine real data like massive LiDAR or point cloud scans with infrastructure data and provide a way that you could stream that information efficiently to the web and to cloud-based applications. So we created this framework, these cloud solutions called Collage Web, but also Collage Site to be able to integrate scans. And it was mainly meant for construction applications, but a very rich experience on the web where you could do things that you could only dream of a few years ago to do on the web with massive data. Okay. And then last 4 years, I've been in this company, Gilytics, and what we do again, we use georeference data that is located in the real world, and we try to use that to automate the infrastructure design and planning process for sites like power plants or electric substations, and also routing transmission lines or roads, that kind of thing. And what happens, of course, is that data of the real world is very important to do that, and it's challenging to get that data that we need. We need data for the planning as constraints that tell us what is there in the physical world, but also regulations, protected areas. And then when we present the proposals for these infrastructures, we need to present them in a way that is as realistic as possible so we can engage stakeholders and people who live in these areas, and they can give their opinion about what they think. So I'm going to talk now about the challenges that we find in this process. And there are different steps in the process where we need this on-demand data. And that means we need to get data from somewhere in the world where we have this project and we want to accelerate the planning process to get all the information. So we need to get what roads, what buildings, what kind of vegetation is there, what type of soil, and that's difficult. Once we have decided where the infrastructure might be located, what engineers and topographers spend a lot of time doing is going to the field to check the reality, what vegetation you actually find there. And what we ideally would like is to do that virtually or as much as possible to save time and do it on the web, but we need data for that. Then this last step I mentioned, we present the project for approval. That's a usually very long and complex project that has a large impact on the budget as well, because the more time it takes, the more difficult it is to get the permissions, etc. So presenting the project is very important, and we need this nice data, nice 3D environment, so people understand what it means for their city or for their park or wherever we are building this infrastructure. Then once we start construction, we need to track the evolution of the construction. So we need again to capture 3D data about how it's built and manage the assets we put in the field, and then inspect how they might, get corroded or have problems in the future, so it can be maintained. So what tools are available right now that we can use to get the data that we need? There are already some services you can use them from the cloud on the web that will capture, that extract information based on satellite imagery, and they are really nice because you can connect multiple satellite sources in the same application with different analysis blocks like you see here to detect buildings, to detect solar panels, different types of vegetation, etc. We'll see that they have some limitations, but they are really interesting. You can do the same from generic geographical information systems like ArcGIS or QGIS. You can even train your own models to analyze the images and recognize the objects that you need. And then we would like to do the same in 3D, of course, but it's much more tricky. First, if we are basing our extraction on satellite data, currently resolution is from 30 to 50 centimeters. So we get something like you see on the left of the image from Maxar or Airbus Intelligence, this kind of services. And it's really nice because you can get it from anywhere in the world, but the quality is not really enough. You can compare it to the image on the right, where we integrate in our solution, Pathfinder, we integrate different sources of 3D data, in this case, Google 3D Tiles. So much more high definition, but not available everywhere. So what could we do there? There are some interesting companies, startups like Black Shark. They are trying to build these 3D models anywhere in the world based on satellite imagery, but of course the image itself doesn't provide all the detail. So what they do is they substitute objects that they detect on the image, like buildings, by 3D models that should look more or less like the real thing. And they add the trees and they add all these details. The problem here is these details are not real. These look really great and can be used for simulations and games, but they are not really that useful for us because they might confuse someone who thinks this is reality and it's really not. So for now, what we have to do, our customers have to do very often, is to have land-based or aerial-based photogrammetry, so capture with drones images or LiDAR laser scanners, and then we can process that with different tools and we can integrate it in our software. But that's not everything. We also have to detect which objects are in reality, like in our case, what towers, electricity transmission towers, the cables, and all these elements in reality. So AI can also be used for that, and it's evolving and becoming better at detecting and extracting the objects based on the type of object that it is. Okay, so regarding this visual inspection, virtual inspection that we need to do, we can use those LiDAR scans, but also we have integrated Street View and other data that's already available and kind of gives you the first approach, first attempt at finding what's in the field. But of course, again, it's not available everywhere. And these are real images from these events where we present this infrastructure solution to the public or stakeholders. And there's an interesting discussion here to be had between what it's more important. It's more important to be realistic in presenting the information or present it in a way that is really significant to them and allows them to understand the impact. So we'll talk about that later. And then finally, another challenge is how these objects that we generate, these electric transmission lines, can be exchanged with other tools. And there's this whole, we can call them metaverse from Autodesk and other software developers who provide these environments where this information can be integrated and exchanged. Limitations that we currently have, the scope of this 3D data in the quality that we need. AI, it's a very, very powerful tool, but it doesn't give you all that we need. For instance, it can be trained in certain areas, but then it doesn't really work well in detecting buildings in other areas where their characteristics are very, very different. Then you still have to validate this information. Also, AI sometimes fills in the gaps where there's no information. It will fill with surfaces that don't really exist. And that's a problem if you really want just the reality. Then all the semantic information attributes are difficult to capture and also difficult to stream to the applications with the current standards. What is this? All sounds like quite really very technical and engineering minded, but also there's a role for artists and communicators, because when we need to explain about these proposals and present them and discuss them, there are different roles and different stakeholders, and we need to find a way to tell the story that is meaningful to them and they understand the implications, and we also need to understand their stories and integrate them into the process. And another aspect that is very important is how to symbolize or how to filter the information in this spectrum between realism and really having symbols that help to interpret the information that we provide. And that's all from me. I will be available in Discord later for more questions.
Thank you so much. You're not free yet, I'm afraid, Dr. Salvador. We've had a lot of responses. Jesus loved that. Ragad loved that. Thank you so much for listening. So, Dr. Salvador, what are the challenges for people to start using these tools? What are the challenges, obstacles? Is it expensive, training-wise? I mean, can you just pick up and go? Talk to us a little bit about that.
So that's been one of our goals, because typically there are these quite specialized tools, the GIS tools, Geographical Information System, and you need to be trained quite a lot in how to put the data in, how to filter it, make it available, and do the processing. And you need to create these complex models that will do the calculations for you. So the idea of our product Pathfinder is that this can be presented in a way that non-specialists, like for instance, environmental planners, they know what these roads or forests mean for the infrastructure. They just don't know how to put and process all the data. So what we do usually, and it takes time to get on board these customers, these companies, we do a pilot project and we train them, we help them with workshops. So the data integration part, it's easy. And then how you represent in this kind of tool the constraints that planners have, like you cannot build an electric transmission line near buildings, and there are a lot of regulations about that. So we have ways that they can specify that, and once they create a template with these constraints, then they can apply it to many projects. So that's our approach.
And if you were, just for people who might be trying to start this in their country, because we've got lots and lots of people who have joined from across the world, who is using Gilytics? Like, are they private entities? Are they governmental? Talk to us a little bit about your usership, please.
Mm-hmm. So the process of planning infrastructure starts usually at a, let's say, high scale level. There are usually governmental authorities that examine what the situation is in the electrical grid, and they would set priorities. Like, we have a lot of renewable energy produced in the north of the country, but the industrial, area is in the south, so we need to reinforce that. And it's happening a lot now with the energy policies in Europe and other countries. So we have governmental organizations as customers. They usually work in defining big corridors and taking into account, environmental protection and climate change and all these factors affecting the environment. Then the transmission line companies, usually there's always at least a big national operator that creates the high voltage lines, the big pipes for electricity. Also gas companies, and gas companies are using it because we are building the infrastructure for hydrogen. And then you have distribution companies, the ones who get to the industries or houses, and also engineering companies, because this kind of study was typically still done by engineering companies and also environmental assessment consultancy companies. They love this kind of tool because they can provide a much faster service and also get a quick turnaround. Like, usually these projects need to make a lot of changes because there's new data available. People complain about something and you have to integrate that. And with this is much faster, a much faster process.
I feel like a lot of the roundabouts in Kenya would have benefited from some of this this information, but we do not have that. Do you think the data type will become like open data one day? Will it be free? I feel like that might be a bit problematic for cities and countries.
There's for the basic, let's say, cartography information, we already have a good publicly available base in Europe and in North America, also in a lot of countries in South America and Asia. So we have the basic map layout. 3D is much more difficult. There are some countries like Switzerland, they already have all the buildings in the country, just basic shapes, and it's they use standards like 3D Tile or i3s. There are already these 3D streaming services, and it will eventually be extended to other countries, I guess.
Okay. Thank you so much, Dr. Bayarri. I would really, really appreciate you joining us a little bit later for our panel discussion on the metaverse. But
sure.
For now, I'm going to cut you loose